All right, so we have learned a lot here. We understand now to use relational operators to control our flow using if statements, of course. The next thing we're going to learn about is going to be logical operators. So I'm going to keep down here and add this logical operators. So in conjunction, if we put together the logical operators and the relational operators that we learned earlier, we can have a lot more power as to how do we create this control flow in our code. So what are the ones that we're going to be looking at? In this case, logical operators. We're going to look at the AND logical operator. So it's going to be AND, that's this, which we use the two ampersands like that. Two N's, that means the end. What is that going to do to us? Okay, coming back to our variables here, our if statement. Let's see if we can use AND and see if something's going to happen. So if I say, for instance, second age, and I say AND first age, we have a problem. The reason why is because second age is a double, and first age is also double. If you hover over here, operator AND cannot be applied to double. That means these must be applied to what? You guessed it, it must be applied to booleans. Because if I say is age, actually, say is age like that, and is age, of course, like that, then we have no problem. But of course, is age and is age, they're the same thing, so that would make no sense. So what I'm going to create another boolean here. Say is not aged to be false, and let's change this to be, actually, is age to be true. There we go, as it is. There we go. It's not age, is false. Now this will make more sense. So let's see what's going to happen. Which of these statements will print? Save and Control R. Can't consume beer. Obviously, this message can throw us off, but in any case, we're just interested to see what will print. So let's do a little bit of detective work here. So is age, we said here, is true, and false is not aged. So that means if we say true and false, because indeed this is true. Oh, sorry. I need to put is aged here, folks. My bad. There we go. All right. Let's run again. Not allowed to consume beer. Okay, this is going to be more appropriate to what we're trying to show here. Thank you for your patience. All right, so now that we have is aged being true and is not aged being false, that means we have true and false. And yet, what we're getting is the else statement here. That tells us whenever we have a false, or in this case true, and a false, doesn't matter the order really, but in this case, is age is true and is not age is false. That means if we use the AND logical operator, the whole expression here will return false. So here we have to say returns false if 1 is false. Right? Because is age is true, is not age is false, and we say is aged and is not aged, the return is going to be false. Because of that, we get else running. So logically, no pun intended, it tells us that the AND operator, logical operator, only takes one of the sides to be false for the whole thing to be false, right? Because if I change this to true, obviously everything's going to be true, which means then this consume beer should run. Can consume beer. Okay? Very good. There we go. Now, you may have noticed by now, everything has the opposite in programming. That's the beauty of programming, right? We can undo things. There's always the opposite. Now, what is the opposite of AND? Well, the opposite of AND is going to be OR. Now, OR, we represent it with two pipes as such. Let's see. If I go here, down here, and I haven't changed anything, and just put the OR, let's see what's going to happen. If I save this, in fact, before, let's make this false. So you can see the difference. So if you run, can consume beer. So OR is age true or false, is not aged, then it's going to run the first statement here, can consume beer, because this will return true. So it turns out for OR is the opposite of AND because returns true if one side is true. The other side doesn't matter. So if one side is true, the other side is false, the other side I'm talking about is in this case here, right? So if one side is true, the other is false, this expression will always return true, hence this will run. Okay, so or is the opposite of and, or and is the opposite of or. These are logical operators. But also, we have another logical operator which we talked about earlier. So this negation here, it's actually not a relational operator. In fact, I'm going to get rid of this here. What is a relational operator is the negation plus equal, the not, as we saw here, right? So this is actually belonging here, right? In negation here. This is where it belongs. So you know what it does now because we talked about earlier. So that means if I come here and I negate that, what do you think this is going to happen? Is not aged is false. What is now? Let's save and see. It's going to say consume beer. Still the same results because this is now true. But it doesn't matter because we said it's or. As long as one is already true, this doesn't matter. It's always going to be true, this whole statement here, or expression, I should say, right? But if I come here, let's say, not, I'm going to complicate the things now, save this and run. Can consume beer is still working because this became true and this became false. So if I get rid of this again, you notice now that we have a problem, not a problem, but we notice now things change because its age instead of true is now false, or is not aged is false. So now we have two false. If we have two false, then there's no way everything is going to be false with or, as well as with and. So the moral of the story here, before I lose you, and is opposite of or. So with and, we need one false for everything to be false. With or, we need one true for everything to be true. But in both cases, if we both are false, obviously, everything's going to be false, right? That makes sense. All right? Very good. So now you know these logical operators and you know these relational operators. You can put all of those together, meaning I can create a more complicated expression here. I can say, for instance, let's get rid of this so we don't get all confused. I can say if is aged or is not aged, right? I can say then and first age is greater than 12, then this is going to happen. Okay? So let's see here. What I like to do in this case, I like to compound things. So because I know this is one expression, I'm going to put it like that so that it's evaluated as one. And then this, if I want to, I can also do that. Okay, so now we have two expressions here, which makes the one whole expression here, okay? So now what's happening here, it's going to go ahead and evaluate this expression. So is aged or is not aged. This is going to be what? True, because one is true, the other one is false. So this is true. So this true here, and first age, it is indeed greater than 12. So we're going to be true and true. It should be true. So we should see this consume beer. Let's see if that's true. Save, run, and can consume beer is there. Ah, very cool. Now, this is a little bit confusing at first, but break it down, right? So what I want you to do now before you go to the next video is I want you to play around this concept, and before you even compile and run, I want you to play a game of detective. Figure out what will run or what will show here in our console when you put different logical operators along with the relational operators. Play around with this concept and see what you can come up with and make sure you understand what's really going on here. Again, remember, break things down as I showed you here so you can get the result.